have Don Wilcher with us, and he's going to talk to you about creating cool projects with Arduino and electronics. Don is a passionate teacher of electronics technology and an electrical engineer with 26 years of experience. He's worked on industrial robotic systems, automotive electronic modules, systems and embedded wireless controls for small consumer appliances. While at Chrysler Corporation, Don developed a weekend enrichment pre-engineering program for inner-city kids. He is the former department chair for the School of Electronics Technology of ITT Technical Institute at the Madison, Alabama campus. Don is now an Electronics and Robotics Instructor at Lawrence County Center of Technology. Folks, we're very excited to have Don with us today to present this webcast for you all. As we get the event started, I would like to go over a little housekeeping to help you get the most out of today's webcast. First, you'll want to open your group chat widget if you haven't already done so. This is where we can interact with each other during the event and where you can submit your questions for Don. We find that our audience usually has a lot of good knowledge to share, so we encourage you all to chat freely during the event. However, if you have questions for Don, please preface them with a capital letter Q so we know that they're for him and we can make sure we see it for Q&A. You can also open, move, and resize any of the other widgets. If you would like to tweet from the Twitter widget today, you might need to give it permission to access your account. The Twitter widget will automatically append the event's hashtag to your tweet so you don't have to. And today, folks, our hashtag is Arduino, all one word. If you should have any trouble with the webcast, please take a look at your help widget. If you continue to have trouble, just post it in the group chat and one of our staff will help you right away. If you have choppy audio or stalled visuals, please try refreshing your window. And remember, the best thing you can do for a good audio stream is close any apps that could interfere. People always ask, so we'd like you to know we are recording today's webcast, and we will have the archive ready usually within 48 hours. And folks, at this time, it is my pleasure to turn the program over to Don for his presentation. Hello, Don.
How you doing, Yasmina?
Hello.
And what was that?
We're thrilled you're with us, Don.
Okay. Because I have a tendency to just dive into the lion's den, but I want to welcome everyone to this session, Create Cool Projects with Arduino Electronics, and I'm really excited about this session as well as the book. Just a quick little background about how this book was manifested. I had two great editors, Brian Jepson and Patrick DeGisto, and those guys really pull a lot of creativity out of me. You know, being engineers, we get kind of stuck in our own little technical world, but those guys were able to pull the voice out and again, the creativity. And that's what this session is about. It's being able to explore the Arduino using some electronics components and kind of talk about a little processes, some tool stuff. So I'm going to go ahead and get started with the slide deck here, and let's go ahead and see how we can make some cool projects with Arduino. Okay, as most of you know, the Arduino, it's the buzz, right? And there's a lot of books that have been written on it, from making robots to wearable technologies. So this book is looking at it from a different perspective, and that perspective is, there's a kit that's out there called the Arduino Microcontroller Pack, and when that kit came out, and I actually have the kit, there was no user guide. It was just a box full of parts. So that was one of the motivations for writing the book is, hey, you got this great kit, but what can you do with it? So on this slide right here, these are a couple examples that you'll find in the book in terms of what you can do with the Arduino. So you can see you can make some toys. you can create sound effects with it. You can make instruments. In this case, this instrument is a metronome, which helps you to tune your instruments. And of course, you can make some games. So if you haven't bought the book, I encourage you to do so, because again, the projects are user friendly. We laid it out in terms of lots of graphics, and of course, we provide the sketches or the Arduino code, so you can play with your cool creation. So, the question is, how do you start to make a cool Arduino electronic project? And notice I got the word device, because that's what it's about. It's about making gadgets and devices. So what I did was I created a process, and again, being an engineer, this is one of the models that we use. It's called the V model, and it's used extensively to design all kind of consumer electronic products. And being in the automotive world, that was one of my my areas in terms of managing a process to develop electronic control modules, or in the case of making a robotic system. So when you look at this diagram, you can see it looks like a V. And what we do is we have two legs of the V. On the left side, we have what's called the design phase. So this is where you get into the creativity part. So you can see the little call out at the top, and it says, well, you got to decide on what you want to make. Okay, that's the first thing. And we're going to talk about ways of stimulating creativity in terms of how you can make your cool Arduino electronic device. So once we get into the actual left side of that V, the first thing you want to do is draw a block diagram. And what a block diagram is, just basically blocks with arrows connected. And I'll show you an example for a project that's in the book. It's called the Magic Light Bulb. And you'll see exactly what a block diagram is. But that's what it is. It's just a top-level way of gathering your ideas and saying, okay, what does it take to make this device or gadget that's in my head? So once you have that, then the second thing you want to do is you want to draw a circuit schematic diagram. So now that particular area is going to allow you to really, what I call, do a deep dive, meaning you have your circuit blocks, and then for each circuit block that you create for your overall block diagram, now you're going to actually make the diagram that's going to allow you to wire up your cool device. Once you have that, then the next thing you need to do is, okay, what parts do I need? So you're going to create a parts list. So that's your little shopping list that will allow you to, construct your device. So now we just finished that left side of the V. Now we're going up on the right side of the V, and this side is where the fun begins. You can actually build your device because you planned it on the left side. Now you're going to actually build it on the right side. So I don't know how many of you folks are familiar with Fritzen software, but it is a really dynamic package, meaning you can create breadboard circuits, and from there you can create your circuit schematic diagram, and once you have that, then you can use those two documents to actually build your device. So, and it's free. That's the cool thing about what's happening with this whole Arduino makerspace phenomenon that's going on. All the tools that people are demonstrating and explaining to hacker spaces, to maker spaces, all these tools are free. So if you ever get a chance, after the webcast, I would encourage you all to Google Fritzen. It's spelled Fritzing, and of course it's on the diagram there. And it should be like the first hit of the suggested websites. And you click on it, and again, it's a free download. They have a nice tutorial that will walk you through in terms of how to construct your little breadboard circuit that you can use to build your device. So once you have that, then the actual fun begins where you build the actual device. So that's where you can use either the circuit schematic diagram that you created on the left-hand side of this V model, or on the right-hand side, which is the first little bullet that you see, you can use the breadboard version of the Fritzen diagram. And I'll show examples of how that's going to look when we get into really looking at how to make a cool Arduino electronic device, which in this case is going to be the Magic Light Bulb. So once you have that, next thing you do is you test it. But prior to testing it, you have to download the Arduino sketch or the actual computer program, and that's going to bring your device to life. So once you have that, then the last thing that you're going to do, what you see right there, is you're going to have fun with it. Okay, and that's the cool part, is you get to share it with people. As you play with it, people will give you suggestions on how to make modifications. That's the creative process. And if you notice, there's an arrow that's going from the side of where you have fun with it to deciding on what you want to make. And that's where you keep making. Okay, I tell my students, either at the high school or when I teach at ITT Tech, when you get this knowledge of building and making, it shouldn't stop. It's always this iterative process of constantly learning and growing and developing new gadgets. And as you do that, if you're, like say, you're in a hacker space or maker space, you collaborate with other creative people, and you just keep that whole process going. So this model is continuous. It never ends. It just keeps going on and on and on. And then one beautiful thing about this is, your knowledge of electronics will grow, as well as how to be a real great maker. So what I did here, this diagram, it's a word cloud, and what I wanted to do was just kind of highlight, how do you decide on what to make? So I got some key little areas in here that I highlighted, or words that I highlighted, in terms of devices or gadgets that you can explore. And you can see a bunch of them there. You got the video, you got security. Security meaning you can make a little security system. Video, there are some Arduino sketches out there that will allow the Arduino to actually create images that you can use for your projects. Of course, there's Android devices that you can connect to, like your tablet, your smartphone, and there's a couple products out there like the IO, or they call it the Yo-Yo. It's a little interface board that you can actually hook up to the Arduino and also to, again, an Android device, and you can write some sketches and you can do some cool things with that. Cameras, again, there's a lot of applications out there. So, again, this is one way to stimulate the creative process. You can create a word cloud. You can do a mind map. You can talk to other people. I mean, there's a lot of things that you can get involved with in terms of finding devices that you can explore using the Arduino. So again, it's a very friendly platform to allow you to create anything that you can think of. So in that B model slide that I showed, I talked about the block diagram. So this is the beginning stage or second stage of how do you create a cool project or device with your Arduino using electronics. So as you can see, I'm talking about an example now that's out of the book. It's the magic light bulb. And we have 3 little blocks. And the way the block diagram is set up, and this goes back to the days of computer technology, those folks who are out there who are, engineers or software developers, they can see how this is all manifested. But for the ones who don't, no problem. That's what this diagram is here to illustrate. On the left side, we have a mini push button. And when we set up our block diagram, we start off with a philosophy of saying all input devices are going to be on the left side. So if you got a sensor, or in this case a push button switch, or it could actually be another electronic device that's going to provide some electrical voltage or current, it's always on the left side. So in this example, we have our mini push button switch on the left side. And then I mentioned earlier, to make the connectivity, we use arrows. So the arrows pointing into the Arduino. So now the Arduino is what we call the brain, the CPU, or the processor. Okay, so we have the input on the left side, and then we have our brain, which in this case is Arduino, which is the processor. So it's going to take that information, and it's going to do something for us. That something that's going to do is based on the sketch that we create and we upload to the Arduino. So once the Arduino sees that little signal that's coming from the push button switch, the electrical signal, then it's going to create electrical signal that's going to turn on an LED. Now this LED is a special LED. It's a red, green, blue LED, and it's one package. When I did a workshop last Tuesday at the Huntsville Public Library, I actually had one of the projects for the participants to build, and it was the secret word game. And it had a RGB LED, but unfortunately the kit that they had didn't have the RGB LED, the red, green, and blue LED. So I told them, okay, we can actually make our own by taking those three colors, meaning finding three individual LEDs, and we can wire them up such that the Arduino will be able to turn those colors or the LEDs on at the specified moment that is in the software where it tells it to, okay, turn on those LEDs. So again, as you build devices, you start to learn tips and tricks to still meet the overall goal, and you can make great things happen. So again, the RGB LED is the output block. So if I was going to summarize this in terms of the process of creating a block diagram, again, the inputs will be on the left, your brain or your CPU, central processing unit, in this case the Arduino, will be in the center, and then you'll have your output device, which in this case is an RGB LED, and that's how you do design. Okay, so design is not as mysterious as most people think. It's a simple little model. This is a model, and from this model you can really make some cool devices with the Arduino. Okay, once you have that block diagram, now we get into the circuit schematic diagram, and I'm going to expand my screen here just a little bit. Okay, so as an electrical engineer, we use this type of method of communicating with each other quite extensively. And what you see here is a bunch of squiggly lines, and they're all connected to a little block in the center, which is the Arduino. Now, what's really cool about this diagram is it's bringing that block diagram to life, meaning on the left side, and hopefully you can see my little arrow, my cursor here. On the left side, we have our switch, okay? So that was on the left side. So when I do my schematic diagram, I always start with the input being on the left. Again, whatever device that is, it could be a switch or a sensor or some other electronic device is going to give me a signal that I want the Arduino to read. It's on the left, so that's why I got my switch on the left. Okay, in the center you see the actual Arduino, so that's the processor. Okay, and then finally we get to the output, and notice I have my LED along with the resistor on the right hand side, and it's like reading a book. We read from left to right. That's how we set up our designs, meaning from an electrical engineering standpoint. We set it up the same way, the way we read. We have our inputs on the left. We have the main content in terms of when you start reading, it's in the middle, and then of course you get to the conclusion, which is at the end. Well, our conclusion in this case is the RGB LED. Okay, so a few little electrical terminology that I'm throwing around here. If you're not familiar with a resistor, and here's one right here, and there's another one. What a resistor does is it takes the little electrons that are flowing through a piece of wire, and it slows them down a little bit. Electrons get real excited when they go through wire, but what we have to do is whatever device is connected to it that's real sensitive to their excitement, meaning they're all rushing to do something great, meaning turn on a motor, or in this case turn on LED, we have to slow it down, because although they're excited, the device that is connected to them, they can become overwhelmed, meaning those electrons are rushing at a very fast rate, and when it reaches, in this case, an LED, well, the LED is panicking, okay? And when it starts to panic, well, it fails. So what we do is we put this resistor in just to slow down those little electrons so that the LED can receive those electrons in a user-friendly manner, okay? They won't be overwhelmed. They'll work together, and that's how we control or save the life of an LED by putting a resistor in there, okay? And that's the same thing that's happening down at the bottom of the switch here. We're doing a little bit of current management, meaning we're slowing down those little electrons, but also we're also creating a little signal that tells the Arduino, hey, that push button is been pressed, okay? Because again, the Arduino is looking for information. Information comes in a lot of different forms and different packages, if you will. This package is basically a little bit of voltage that is on the Arduino board. It's a little 5-volt supply. And we're going to take a little bit of that energy, that little voltage, and we're going to tell the Arduino there's a switch that we pressed, and therefore the Arduino knows once the switch is pressed that it can turn on the light bulb, or in this case, it's going to turn on the LED, and then we get to see the magic happen. So we have our block diagram created, we have a schematic, and now we start doing the shopping. Okay, we go to Radio Shack, we can go to Maker Shed, there's Adafruit, there's SparkFun. We can buy these parts, but again, if you have the actual kit, the Ultimate Microcontroller Pack, all these parts are in the kit, which again makes it convenient. So you can see here, these are the parts that we're going to use to build our little magic light bulb. Okay, so we have, of course, a microcontroller. There's a Maker Shield kit that you have to assemble, and you can go online and actually get the instructions. And this is a really nice project in itself because it allows you to learn how to solder. So if you never learn how to solder, the directions that are online, which was produced by Make magazine, you can download it and just follow the steps. For any kids out there that are in the audience, again, this is a great project for you to learn about soldering because there's a lot of projects that occasionally you want to make permanent, meaning you don't want the parts to fall off real easy. So when you do this project right here, it'll give you the knowledge and skill to actually build other electronic devices via soldering. Okay. Now there's two resistors here, and we talked about what a resistor does. It's basically there to just slow down the little excited electrons that are flowing from the power source, meaning in this case a 5-volt power supply that's on the Arduino board. Well, resistors have these little stripes, and there's a color code that's associated with it. Now, if you venture into electrical engineering, one of the things you have to learn is how to read that resistor color code. So what I did was, again, not getting into that nitty-gritty world of electrical engineering, I put the color code for you. So when you look for these resistors, all you got to do is just look for the stripes there. So this 330 ohm resistor, and that symbol right there looks like a horseshoe. That's ohms. It's omega, but we use the word ohms because that's the unit for resistance. We find this part in the Ultimate Pack. We got to look through all the resistors, but this is the one that you're going to use for helping to keep the current, or I should say the electrons, from overwhelming the LED. So we have this 330 ohm resistor. It's orange, brown. Okay. There's also a little fourth color. It's gold, and the gold is just there to say, okay, based on temperature or there's current that's flowing through it, it might change that resistor value just a little bit. So we put a little window, which we call a tolerance, And as long as we're within the tolerance, in the case of these guys, it has a gold stripe, it'll be within plus or minus 5%. Okay? So the next resistor is a 1K ohm resistor. Again, there's the color code for you. It's brown, black, red, and you put that on your circuit at the right spot. Of course, we have our infamous red, green, blue LED. And I would encourage anyone, again, I tell my students, when you first build these projects, you follow the recipe, and once you have an understanding of how the recipe comes together to make, a very nice meal, if you will, you can explore experimenting with using individual LEDs. So again, when you look on the schematic, you'll see the red, green, and blue LEDs, but they're in a package, but you can actually buy these little LEDs individually, and you can get the same result. Okay, so again, that's part of the experimentation. So we got all our parts. We got the block diagram. We have our schematic. So this is a good example of the Fritzen software. The schematic that we looked at a couple slides earlier came from the Fritzen software as well, but when you first start Fritzen, it has what's called a breadboard view, and that's what this is. This is the actual breadboard, and then what we do is we have our parts list. So we start going into this little virtual electronics bin of cool components, and we start putting these parts on our breadboard. Now, a lot of times I get questions from students saying, hey, how do you know where to place these parts? Well, the way I always like to start is I like to start from left to right. So the way that you see how these parts are placed on the breadboard is using that philosophy. I've got the switch located on the left side of the board, and on the right side of the board I have my LED. Now notice, I'm going to zoom in here on my screen here. Hope you guys can see this too. If you notice, this is a little mini breadboard. The kit, meaning the Ultimate Microcontroller Pad, it has a full-size breadboard. It's clear. I'm not an advocate for the clear board. Sometimes it confuses me when I'm wiring up a circuit, but some people, they like it because they can actually see how to lay their wires out. And also, the nice feature that I do like is it shows the construction of how the breadboard is built, so you can understand why these particular five little dots on the board are positioned the way they are, and how to really wire up a circuit without, say, creating a short circuit, meaning two devices that should not be connected. That will be considered a short circuit. So, again, going back to the block diagram philosophy, I have my switch on the left-hand side placed on the board, and then I have my RGB LED on the right side. And of course, in the middle, you can see here is the Arduino. So again, that's how I kind of lay out my board. Also, one thing I do is I try to keep everything kind of closely compact, meaning the wiring, all the components are pretty much in the same area, because if I wanted to add another part, then I have some more available space to do that, like on this side. Now, the full-size breadboard, it's full. So you got lots of space to add other circuits, do other experiments on that board, and you can kind of make it what I call like you can change the personality of the board, because you can make one section, say, a little DC motor controller project, and then the other side of the board you can make for an LED project. And just by moving these little jumper wires that you see here, you can change the personality of the Arduino, meaning you upload the sketch to the Arduino, and that's where the magic happens, okay? So hopefully that gives you guys some understanding of how to lay out a breadboard. Again, I've been doing this, for a couple years, You get practice, and that's the whole thing, is constantly keep practicing. So that's why that slide that I showed previously, the B model, it has the arrow going back to the left-hand side because, again, you want to continue to build your knowledge of making cool devices, learning more about electronics, and just sharing your creations with the world, okay? So I'm going to minimize my screen here, all right? So now that we got our breadboard, which is our roadmap, we build the project accordingly, and you can kind of see how the parts are laid out. We have the switch on the left. We have on the right, we have the LED. Now, this is the maker shield that I was talking about. And I really like this product because, again, the whole concept behind the Arduino is to make these little electronic gadgets that you can put in a pocket, or if you got a little toolbox, you can put it in your little toolbox, and you can, wherever you go, if it's at school, you got a science fair project you want to set up, you got this nice little electronic module that you created. Likewise, at a hackerspace or makerspace, you can share your creations in a portable fashion, and it makes it easy to transport. So this shield sits on top of Arduino, and the concept of the shield, well, even though this is on top, but if I rotate this guy, having it stand up, the shield will be actually in front of the Arduino. So it makes the personality real easy to change, meaning you can have multiple shields, and by downloading the software, you create a new device or gadget, okay? So, again, that's how I laid out this particular board using that philosophy, okay? So now, the next thing, let me minimize my screen here, is what we're going to do is we're going to, we're going to have fun with it. Oops, there we go. We're going to have fun with it, okay? And that's the whole magic behind the Arduino, is to have fun with it, to share it with a lot of folks, and to, again, constantly be involved in this maker mentality of, hey, I want to make something cool to show my friends, my family, or if you're doing a science fair project, I mean, the Arduino is great for that. There's a lot of resources on the web that will allow you to do cool projects for science, or if you're starting, say, going into engineering, they use this same type of tool to teach electrical engineering or electronics engineering and software programming, okay? So what I want to do now is I'm going to just show you the result of this little magic light bulb. And I did a little video this morning of the project working. So I'm going to go ahead and share the screen here. Let me get my little video up. So I'm going to do that right now. Let me minimize this. And video going. Okay. So hopefully you guys can see this. Okay. So with each push of the button, you see the colors changing from red, green, and blue. And the timing is real short. But the whole concept behind this project is, you have some friends and you say, hey, I have this magic light bulb. And, of course, they're going to look at you like, what do you mean you have a magic light bulb? That doesn't look like a light bulb to me. You can say, well, it's an electronic light bulb. So once you have that, you have them close their eyes, and you say the magic words RGB, and you say that 3 times, and then you press the button and you say open your eyes, and guess what? There's the magic, right? It's this nice little device that's changing colors in front of our eyes, and hopefully the wow factors there where they go, wow, that's pretty slick. How did you do that? I want to learn how to make one of those. And that's the whole point behind the Arduino. It's a real nice tool to communicate creativity, to get a lot of people excited about technology because, as we know, technology is just everywhere around us. And it's nice to be able to build a technology device, share it with people, and get them excited about it. And, you know, when I did that workshop at the library, the Huntsville Library last week, I got that same result. I mean, there was some high school students there, and man, I mean, they were really into it. They once they saw that project work, which was the secret word game, they got really excited about, hey, I would like to get my own Arduino. Where can I buy one? So that was, I'm trying to get back to the slide here. That's where the magic happens, okay? They get excited, and that's the whole thing. It's you're being a contagious agent, if you will. So I love the Arduino. I think it's just one of those cool things that anybody with no experience in electronics can really get into it, and that's why the book was written. And again, I appreciate you guys coming out and just hearing me talk a little bit about the Arduino. Oh, one more thing I want to do is, since I have this up now, the share screen, I want to show you, if you've never seen what a sketch looks like, I can show that right here.
And Don, this is Yaz. Can I trouble you to reshare your screen with us so we can see the sketch?
Okay, yes. I'm doing it right now. Thank you for reminding me. Okay. Can you guys see it? Hopefully you can see it. Can you see it, Yasmin?
Not yet. Not yet.
Okay.
You might have to relaunch it by clicking that play button again.
Okay. Let me go back.
Okay, here it comes.
Okay, great. Okay, let me minimize that. Okay. So can you see, Yasmina?
Yes.
Okay, great. So this is the sketch. I just maximized the screen so you can see it. But when the folks at Arduino created this language, it's using a high-level language called C. And what they did was they kind of watered it down because really the Arduino wasn't meant for engineers like myself to be writing high-level programming applications. It was written for visual artists or anybody that say, hey, I want to make an electronic device, but I don't have the background in programming. How can I do it? So, and you can actually see this sketch. It's in the book, in the chapter, but it's laid out. The way I laid it out is in a format where, you know, I got some statements in here. I explain what the project's about. Okay, so it flashes the red, green, and blue LEDs of that of the RGB 3 times when you press the switch, and you guys saw that in the video. Okay, then of course I put the date on here and my name. Now, one thing about when you start creating these projects and you start writing sketches, it's always important to document, you know, the information related to your project, because again, if you come back to it, say a week or maybe a year later, and you want to make a revision to it, you got to have something that's going to help you to understand, hey, what was this device that I created, meaning the software or the sketch. So it's always good to put, you know, these little notes in here. We call them comment statements. So you put this comment in here, you can see the date origination, which is kind of cool because it's going back into time, right? So I did this in February 2013. You can see the day that I created this sketch. So it's kind of like, wow, that's pretty awesome. I created this nice little sketch for my project. So after that, what we have to do is we have to set up the pins that are going to control the LED. So I got a comment statement here that said, you push the switch and the RGB pins wired to the Arduino microcontroller and I say give it a name. So these are the names. These are actual pins that are on the Arduino. So if you remember, I showed the circuit schematic diagram, and it's also on the Pritson breadboard. These are the actual pins, but what we want to do is we want to use names that mean something, and these are the names that I chose, which is the red LED, I got a green LED, a blue LED, and I got a push button, okay? So here I got this little variable that's for the counter, because what I want to do is I want this device to control each of those LEDs. There's 3 of them, but I want to have a little delay between when those devices turn on. So this right here is setting up a counter, and we'll see that shortly, how that counter is configured or documented in the sketch. The next thing we want to do is we have this value that we want to pass, meaning the actual data that's coming from the switch. So we create a variable, and this variable is a little container. And all it does is it looks for when the push button is pressed, and if it's pressed, it will take that information and it'll pass it to the Arduino, and then the Arduino will turn on the LEDs based on the sequence that we establish. So the next thing we do is we have this setup, and the setup is where you really, well, define how it's going to be built. So I have what's called the pin mode, and what the pin mode says or explains to the Arduino is, hey, I got these three LEDs, and I want to make these pin numbers, which you see here, 9, 10, 11, and we have the names associated with them, but I want those guys to be outputs. So again, going back to that block diagram, it's about the inputs and the outputs. So the inputs are on the left side and the outputs are on the right side. So that's where it's telling me the Arduino is these 3 LEDs, we're going to make those outputs, meaning we're going to send information, in this case, electrical current, or those little electrons, to those LEDs to turn them on. And then, of course, we have our input, and that's our push button. So pin 8 is where we have our push button, and we make that into an input, okay? So once we have that, now we're ready to set up how we want this device to work, okay? So right here, I'm using what's called a digital write, and a digital write is like a switch, okay? I got 3 switches, or I should say I have 1 switch, but this switch has, imagine like a rotating switch, and it has a knob. So I've got 3 positions that I'm going to turn this knob, and when I turn it into one particular position, it's going to turn on that device. So in this case, I'm turning it off because the way the LED works, we don't want it on initially. So I'm telling the switches right here to turn off the LED by making this output, it's a high, okay? And the high is, it's a binary level, and the binary deals with bits 1 and 0, or in this case, in terms of voltage, it's either a 0 volts or 5 volts. So I want it to be off, and by setting up the way you see here, that's how we're going to turn it off, okay? We're going to put a high or a binary 1 on that little LED, and it knows, okay, I'm not going to accept any electrons. So those guys are off initially. Now, once we set up turning off those LEDs, now the fun happens, and that's where we have our container that I mentioned earlier. We have this push button status, and now we're going to take the information from the switch, meaning once we push the switch, we send data to this container called push button status, and the way we do that is we use this digital read. So it's going to take the data, it's a container, it's going to take the data, and then it's going to pass it to this other container called push button status, and now the Arduino knows, oh, it's going to think about what's going on. So we have this if statement, and it's saying, hey, if that container known as push button status is equal to high, meaning that push button is pressed, and I have the comment here, I'm going to actually start the LEDs. Now, when I start the LEDs, one thing I want to do is I want to get my counter ready, and the counter is going to create the delay, okay? Because I don't want all these LEDs to basically, when you push the switch, you just see the LED turn on, and you can't see the individual colors turn on. So I'm slowing it down with this counter, and this is a special counter. It's called a 4-loop counter. So it's telling me that, okay, I'm going to slow it down by going through these 3 LEDs, and it's going to count. But it's going to count real fast, and it's going to switch between these LEDs. And I'm going to turn them on now. I'll turn on the first one, and then I'm going to slow it down a little bit further. I'm going to slow it down by 1/4 of a second, and that's just enough so you can see it. Okay. Then I go to the next LED, and I'll turn that one on, but I'll turn the other one off because I don't want the previous LED on. And this is the pattern. Okay. You can see how the pattern is turning on the LED, the one that you don't want, the one that you don't want on, and it's turning on the one that you do want on. And you just repeat this. And it'll do this 3 times. That's what's happening with this counter. It's going to do it 3 times. So in that video, I don't know if you saw it, but it was actually turning on these LEDs 3 times, and then it stopped, and then I push the push button again, and then it repeats the pattern. Okay. So that's how this little program, the Magic Light Bulb Sketch, is set up. And if you don't know anything about programming, no problem. There's a lot of resources out there on the Arduino homepage. It's arduino.cc. Also, when you download what's called the Arduino IDE, and IDE is another tech term that we use in engineering. It's called the Integrated Development Environment. And what that means in a nutshell is you have tools, meaning you can write your code, you can upload your code or sketch to the Arduino, and also if you wanted to display messages, it has a little built-in monitor that will allow you to do that. And I'm going to slide this over here so you can actually see the monitor. It's this guy right here. So if I click on this guy, if there was data being passed, you will actually see that data. So right now it's saying, hey, there's nothing connected to the Arduino, okay? So if I did connect it, you'll actually see this little blank screen, if you will. And if I had little messages embedded in my software, I will actually see these messages come across the screen. And that's a nice little effect, too. In the book, I have projects where if you want to, say, look at temperature, or you want to display the word hello world, that's what's in the book. I have these examples that show you how to set up the monitor, and you can, these sketches, and you can actually see these little messages come across the screen on the computer, as well as what a device called a liquid crystal display, and you can do some nice little projects with that too. As a matter of fact, the secret word game that I showed is one of the example projects you can make. It does that. It actually shows messages, and you basically follow the prompts, and then you can get that game to work. Okay? So I'm going to stop that and get back to the screen. And so we got 48 minutes, and we got about 12 minutes left. So now I'm ready for some questions.
Excellent webcast, Don, and we do have a lot of questions that have come in, so I'll just take them in the order that they did come in. Okay. Jerry would like to know, when is Zero coming out, and what is the cost?
Oh, that is a very good question. I'm looking into that myself. I get a lot of information that I'm tracking that's on my radar, like the Arduino Zero. And unfortunately, I don't have that information. What I can do is I can get his name, his Twitter handle, or his email address, and I can forward that information to him. But
okay.
Yeah.
Great. All righty. Next question here is from Stefan. Does the fritzing software simulate the circuit?
Unfortunately, no. And that's something that I would think would be a great tool. I use a package called Multisim. It's an engineering software package, and you create the schematics, and then you can simulate them, and you get to see the results, and that gives you a high level of confidence that your circuit's going to work. That's something that is not there. I could probably shoot an email to the Fritzen guys and see if they're working on something like that, and maybe the audience can do the same thing if they're really interested. But no, that feature's not there, unfortunately.
Thank you. Let's see. Next question is from Dean. He would like to know if you could talk a little bit about pull-up and pull-down resistors and their use in microcontroller circuits.
Oh, gee. Okay. That's a pretty high-level question there. Well, what a pull-up resistor does, let me back up before I get into that. One thing about digital circuits or microcontrollers, one thing we have to do is we have to make sure that the pins that we're using are terminated, meaning either it has a resistor, meaning pull-down resistor, or pull-up. Okay. If we don't do that, what happens is electronics, it's noisy in itself. So with a lot of these products, they have these little clock switching circuits going on, and these little electrons are looking for a home, meaning they want to go back to ground or the negative terminal of the battery source. So the best way we handle that is we can pull up resistor. When we put a pull-up resistor, what it's doing is that pin that's connected to that resistor, whatever voltage is on the other side of that resistor, that's what that pin's going to see. So in the case of we have a pull-up resistor going to 5 volts, that pin is going to see 5 volts, meaning if I put a voltmeter at that pin, for one test lead and the other test lead going to ground or my negative terminal of the power supply, I'm going to see 5 volts because, again, I'm pulling up that voltage, okay? A pull-down is just the opposite. What the pull-down is going to do is going to ensure that the pin is going to see 0 volts. And without getting into a lot of electrical circuit theory, because it's a little bit more behind the scenes than what I'm describing, but that's basically it in a nutshell. The pull-down is going to make sure that there's 0 volts at the pin, and a pull-up is going to make sure the pin sees the supply voltage, in this case, if it's 5 volts or 3.3 volts. Okay?
Thank you very much. Let's see here. Next question is from Earl. What are the prereqs for your book? Do you need to know basic circuits and electronics and programming?
Oh, that's a good question. And that was one of the discussions I had with the two editors, and the answer is no. When you look at the book, the way the book is laid out, and I had some examples of the magic light bulb in terms of the breadboard. The breadboard is really the heart where if you don't know about circuit schematic diagrams, you just follow the picture as closely as possible. We also have actual pictures that will guide you too, because unfortunately Fritzen, it has this funny thing where it's got to make 90-degree turns, or the wires are going to be diagonally. They don't make nice little loops like you see in the actual product, but it's a roadmap. So that's, again, you don't need a background in electronics. You just need to, read the Fritzen diagram, use that as your guide. You got the pictorials that are in there, and also I mentioned like the resistor value. I specify what those colors are so that you can find them in your kit or your junk box of parts.
All right. Thank you very much. A couple more questions here. This one from Steve. What does the void statement mean in the code?
That's a very good question. The void statement in C language is basically where you can actually set up what we call the main body of the code, or we can set up a function, okay? In the case of Arduino, there's a couple of, say, little modules or functions that they created. One is the setup, and it's a module. So if we want to make a module, we use the word void and then the name of the module, and then we have these little open brackets, And the open brackets means that there's no information being passed from another module, okay? So we have a module called setup. We have another module called loop, and that's where we stay in this loop continuously looking for, in this case, a push button being pressed, or if we're going to turn on a series of LEDs, it'll just run continuously within that loop. So that's what the void statement is. It's just a way of creating a module or a function to allow a microcontroller, in this case the Arduino, to do a specific task.
Thank you. Let's see here. A couple more questions. This one from Anthony. Does the fritzing software help you work out what resistors you need? If not, what is the consequence of using the wrong resistor?
Okay. What the fritzing software allows you to do is it's a planning tool. You know, that breadboard view that pops up first when you initially open up the fritzing software, it allows you to map out, okay, how do I want to lay out my circuit so that I can build it? It does not give you any clues in terms of what resistors to use, meaning values. That's where if you read or find another source, there's a great book that Make has. It's called Make Electronics, and also Charles Platt, who's the author of that book, he came out with a second edition called Make More Electronics. And in that book, he explains how to select the right resistor values that you need for your circuit. And, you know, there's a little bit of math called Ohm's Law. That will help you too. But I think if Earl or anyone else out there that's interested in really getting into understanding, you know, a nice foundation of electronics, those two books are great resources. As a matter of fact, I suggest those to my students when I teach at the two schools. Grab those two books, and they got some real good information in there about resistors and capacitors and other components.
Super. And we'll take this final question from Dexter. Where do you see the trend in no operating DIY MCU versus Linux-based operating hardware?
That is a very, very good question. For a guy like me, I'm always thinking about the future. Okay, and those two worlds are blending. Okay, I mean, you got the Raspberry Pi, that's a Linux-based computer, and then of course you have the Arduino, that's non-Linux. But if you know how to go between those two worlds, you know, you can make some real, I mean, elaborate projects. There's a bunch of examples out there on the web. You know, like go to the Raspberry Pi website. They got some projects related to Raspberry Pi, of course, Arduino. And, you know, one thing I always like to do is I like to integrate this stuff. So in a nutshell, I think those two worlds they blend. But if you need something more specific, like with the Raspberry Pi, it allows you to do a little bit more complex things, like it has video capability, and it's on the board, whereas the Arduino, you have to maybe add a little circuit. But again, those two worlds are blending, so I think that's the trend. It's just having an arsenal in your toolbox and say, hey, depending on the application, if it's high-end, I may want to use Linux. If it's kind of medium to low end, I may want to use the Arduino, or you can, you know, go the other way with the Raspberry Pi. You can go low end too. So really just depends on the application, but I think that's where the future is. It's just there's so many tools out there. Anyone can make a choice and do great things with them.
Super. And with that, folks, I'm going to push out our cover slide one more time here, and this has Don's Twitter handle on it. So feel free to reach out to him on Twitter, and he'll respond when he has time. Don, we would like to thank you for spending your time with us today and for presenting a really outstanding webcast for us all and for sharing your knowledge and expertise with us.
Thank you very much. And to everyone out there, go make something great. Thank you.
all of our attendees today, and we had people from all over the world. We thank you for joining us, and for those of you that stayed up late or got up early, thank you so much. We hope you've benefited from today's webcast. And in closing, we would like to let you all know we did push out a code to you all in your group chat. So before you leave, if you didn't open it, please open it. There's some links in there and some codes to save you some money today on Don's book. It is the O'Reilly Deal of the Day, and you can get it today, the ebook, for 50% off. If you like what Don's been talking to you about today and showing you, you want to get that book. There is so much in there that can really help you with your projects. And for those of you that have children, great projects in there for the kids too. Get them involved early with electronics and this fun type of creativity. They will like it. Folks, we thank you today for attending. This will conclude today's webcast. Goodbye, everyone.
Bye.